Welcome back to Advent of Code 2016, day 23. It's possible I might finish the whole lot right now. Depends how hard these last problems will be. They don't seem to be hard going by the leaderboard stats. So, uh, last time we did 22, which was actually a really fantastic problem. I thought I would say so far that's the best problem of the lot. Really clever. And you can solve it by hand. Well, you need coding for part 1, but you can solve part 2 by hand, and it's actually advisable to do it by hand if you're going for speed. Okay, so 23, safe cracking. So let's begin. This is one of the top floors of the nicest tower in EBHQ. The Easter Bunny's private office is here, complete with a safe hidden behind a painting. And who wouldn't hide a star in a safe behind a painting? The safe has a digital screen and a keypad for code entry. Yeah, of course it does. This whole month is about security and code cracking. A sticky note attached to the safe has a password hint on it. Eggs. The painting is of a large rabbit coloring some eggs. You see 7. Okay. When you go to type the code, though, nothing appears on the display. Instead, the keypad comes apart in your hands, apparently having been smashed. Behind it is some kind of socket, one that matches a connector in your prototype computer. You pull apart the smashed keypad and extract a logic circuit, plug it into your computer, and plug your computer into the safe. Alright, I don't think this is important so far. Now you just need to figure out what output the keypad would have sent to the safe. You extract the assembly code from the logic chip, your puzzle input. Alright, let's have a little look. Okay. Toggle X toggles the instruction X away, pointing at instructions like J and Z does. Okay, fine. For one argument instructions, ink becomes deck, and everything else becomes ink. For 2 argument instructions, J and Z becomes copy, and all other instructions become J and Z. Okay. Copy 1, 2. Wait, we need to know what... Oh, I see. Okay, yeah. So we can actually reuse our old code, some of it. If toggle toggles itself, the resulting instruction is not executed until the next time it is reached. Fine. Seems fine. Okay. I mean, we pretty much just reuse our old code, so... What was it? We just gotta add toggle in, so where is it? It was... day 12. Got all our codes here. Alright, just copy all this. So, alright, we actually want to... I would say split these before we use them. So we'll split them in ins. So now we don't need that. So take these, call them ins. No, what we're doing. Stop. Yeah, take the split out, that's all we need to do. Okay, so this is already handling ink, deck, copy. What was the other one? J and Z. So it's elif. Okay. To compare. So this should now just run. Take this out. So except toggle will be ignored. That's fine for now. What value should be sent to the safe? So the final value of register A is 3. Hang on, so what registers do we have? Is it just A? There's just one register? No, there's A, B, C, D. Alright, just try running this now. Running forever. Because it's an infinite loop as is. Okay, fine. So now we just need to add toggle in. So let me remind myself of, I don't know, I'll just have a quick look at the rules for the previous instruction. So copy copies X into register Y. So I need a check for copy. So if inst, so the second 0, 1, 2 parameter 2 has to be a letter. Okay, inst 2 if not, if it is a letter, we ignore it. All right. Is that the only error that could occur? What else? Invalid instructions. So the only things we do are we swap arguments. Ink becomes deck, all the others become ink. For 2 argument instructions, J and Z becomes copy, and all other 2 instructions become J and Z. Hang on, so J and Z jumps to an instruction Y away. But only if X is not 0. So the second parameter has to be an integer, right? If okay, so those are fine. Ink and deck, I don't think we need to worry about them because ink. Oh, wait. Toggle. Ink and deck always have to be letters. But toggle is always an integer, so we need so it's possible to end up with ink a number, so that was also going to be checked. Okay, fine. Okay, so I've got safety checks for all 4. That's fine. Now what? If it's toggle, so I equals PC plus int. Nothing can end up being toggle, so we don't have to do any checks here. Okay, so int inst 1 if it's within bounds. While PC is less than length int. So, hang on, let me read this again. Toggle A Oh! Toggle can use a register as well as an integer. Okay, fine. So it'll be program counter plus we have to do the same thing we did with the chain set. Okay, fine. So it's like this basically. So it's integer if it's digit. Otherwise, the register value. Okay. So that's the new instruction. If I is less than length of the instructions. Could it be less than 0? Well, if that happens, we'll know. Okay, so if it's within the instructions, we now have to toggle the instructions. So so if length of ins I equal, so let's do the one argument one, so it's 2. Then ins I, first argument will be toggled, so it will ink becomes deck, everything else becomes ink. Okay, fine. So ink becomes deck equals deck if ins I 0 equals ink, else ink. Else equals, so it's J and Z becomes copy. Okay, so copy if it's J and Z, else J and Z. All right, let's try running it. Here, minus 16. So if it's invalid, okay, fine. So, and register, so it's got to be, hang on, it's not in the register, so inst what's the problem here? We're doing copy inst 1 minus 16. What does copy do again? copies X, an integer, into the register Y. Register equals what? Inst1 is minus 16. Oh, the minus sign. It never occurred to me that okay, instead of using isDigit, let's say if not inst1 in ABCD. Let's do that because you can have minus signs and that's not actually a digit. If not start again because I think I've done some of these wrong. Okay, so saying it's not a digit, therefore if ins is in ABCD. If it's not a digit, therefore it's in ABCD. Not a digit. In ABCD. If it is a digit, so it's not in ABCD. Let me go int of that if it's a digit. Not in ABCD. Not in ABCD. Not in. There was a better way of doing this. I could have just made a subroutine that converts letters and numbers to their respective. Yeah, whatever. Now try. Stuck in a loop. Let's check the program counter then. Okay, print register. A and C are just... okay, fine. That's the start. Now let's test the example. $42. Yes, correct. So the above code will set register A to 41, increase its value by 2, decrease by 1, skip the last deck because A is not 0. A is... Okay. So what's the problem with... ...41, 43, 42... 43, 42... Okay. Alright, what is the problem then? I mean, the only thing we've really added is toggle, so maybe it's a problem with toggle. But we also added the ABCD stuff, but... Okay. Let's just check all of these one by one. So copy, if inst is a letter, then we change that to int if it's not a letter, otherwise. Okay, fine. If it's J and Z, so if not, wait, J and Z is, it's J and Z again. Oh, hang on. Ah, J and Z is allowed to use both. Okay, so that's got to go. It's allowed to use both letters and numbers. So let's compare. So we've got to add that. Okay. That was the problem, right? Toggle. Try running that. Still. So toggle is a letter or a number. Ooh, maybe any brackets here. I don't know. Okay. What is the problem? So ink and deck absolutely need to refer to letters, because you can't just ink a number. All right. Copy. What does it do again? Yeah, the second parameter has to be a register. That. So are we checking? If ints to yes, okay. And then the rest equals int. Else. Sure. Okay, that's fine. I mean, this is right. Compare. I just put these in brackets for safety. This keeps going on forever. Is there ever... Should it ever be touching D or B? Probably. Copy A to B. Alright, well... Copy A to B, dec B. Wait, why is B never being decremented? Oh, it does. It's just decremented once. You know what? I think we need to check also that if 0 is less than or equal to... it was probably negative and then it was trying to access from the end, but that's wrong. If I is... Okay, try that now. No, that wasn't the issue. But that does need fixing anyway, because if it's negative I, it's invalid instruction. We're just gonna have to run the first few steps by hand and make sure it's try the example again. 52, yeah. Okay. I mean, the only thing that could be wrong here is the way we've implemented toggle. Surely. Everything else was from before. Shall I retest this on 12? with this new execute, so we can keep the toggle in because it's not going to count the toggle. Okay. Okay, so 12. We're on 12. 0. Huh? Zero, 0. We've broken it somehow. If inst 'What should the answers be? 3108. So it's big. Big should be big numbers. How have we broken it? So if it's ink, deck, copy, JNZ, TGL. Ink, deck, copy, JNZ, and there's no TGL. That's fine. So zero, 0. So if we go back to the old execute, it works. What have we broken? Seriously? I copy this in one by one. So the ink. Now run it. It's fine. Alright. Now the deck. Damn it. Why is it all... Alright. Should be fine. Yeah, okay. And now the copy. Why does it keep messing everything up? Okay, I'll just copy the full lines. Why? Oh, IDE trying to do smart things. It's annoying. Right, now it's not smart. Copy is fine. And then the last one is JNZ. It must be JNZ then. JNZ. So we've got LF. No, JNZ is fine. What the? Oh yeah, we changed this as well. Change that. Okay, it's fine so far. So what? Registered A. So what was the last thing I changed? I added TGL, but there should be no TGL. Just add it then. Well, it's working now. What? So if I copy this whole method, now it works. Oh, for God's sake. Why was it giving me zeros earlier? Whatever. Okay, so... Fine. So those are correct. So the only thing then could be the TGL. Oh. What happened? What did I change? I've now run 23. And it's giving me an answer. Okay, is that correct? What? Why was it in an infinite loop before? Did I change something? I didn't... I was copying this into 12. I didn't... Let me just see what the register's doing. Now it's going up. Oh, no. That's because there's no TGLs. Okay, fine. So there is a problem with the TGL for sure. Alright, let's go back to the new input. Yeah. Okay, so it's still broken. Alright, fine. TGL. Let's iron this out. So let me read the instructions again. Toggles the instruction X away. If an attempt is made to toggle an instruction outside the program, nothing happens. Alright, so it's just the calculation that's probably wrong. One second. Oh, how did I manage to get this calculation wrong? So, I is the program counter plus the integer value of inst1. So if it's 0, then this will just be PC. If I is between 0 and that, correct. Anything outside, you ignore. If length ins I is 2, 1, 2, then ins I 0 I just need to print ins. You need to have a look at this. Okay, so ins I0 is deck. Okay, let me check these again. One argument instructions. Ink becomes deck. And everything else becomes ink. So deck, if it was already ink, otherwise ink, and then else copy if it was J and Z, otherwise J and Z. You only ever change the first parameter, yeah. Toggle toggles itself. It'll become ink. And the resulting instruction is not executed until next time it is reached. Well, that's fine because we increase the program counter. Can the program counter ever go negative? And what happens if... That could be an issue. Let's say while 0 is less than or equal to... Maybe I'm misunderstanding. Maybe it is supposed to take a long time to run. Oh my god. 7 is supposed to be an A. Oh, that's... Oh, that is cheeky. A is... In the example, they set A to be... Well, they didn't say. Hang on. Let me try the example again. I'll try the example. 3. So they set A to be 0 in the example, but it's actually supposed to be 7? Oh my god. That's my fault for not reading. Seven. Alright. There we go. You have to read carefully. But if you're being competitive, you skim. You have to skim. So you can't have it both ways. Save doesn't open, but it does make several angry noises to express its frustration. You're quite sure your logic is working correctly, so the only other thing is, you check the painting again. As it turned out, colored eggs are still eggs. Now you count 12. As you run the program with this new input, the prototype computer begins to overheat. Oh no. Okay. You wonder what's taking so long, and whether the lack of any instruction more powerful than add 1 has anything to do with it. Don't bunnies usually multiply? What value should actually be sent to the save? So we actually have to understand what the program's doing now. Alright, so let's try it anyway. Oh. I thought it was not gonna run. 8232? What? Not the right answer, too low. Wait, have I... As you run the program with this new input, the prototype computer begins to overheat. What are they getting at? I don't understand. Oh damn, no, we can't do this like this because we're rewriting the instructions. Yeah, that's the problem. Now it runs forever. So we have to identify what is trying to replicate multiply. So we had 7. What's special about 13140? 3140. Let's see what its prime factors are. 0, 2233573. Interesting. All right. We have to look at this now and think what's going on and simplify it. So copy A to B. Decrease B. Copy A to D. We gotta... I need somewhere to write something. Where can I write stuff? Wait. New text file. So initially we've got 0, 0, 0, 0. Copy A to B. So it's 0, 0, 0, 0. Decrement B. No. A will be 12. Copy that to B. Decrement B. So it'll be 12, 11, 0, 0. Copy A to D. 12, 11, 0, 12. Copy 0 to A. Copy B to C. 0, 11, 11, 12. This is weird. Increment A. So 1, 11, 11, 12. Decrement C. 1, 11, 10, 12. So far it's... I don't know what it's trying to do. Alright. Jump, if not 0, C to minus 2. Okay. So C. If it's not 0. Okay, so C is not 0. So we're going to keep repeating the last 2 instructions until C is 0. So these 3 commands simplify to actually change the input here. So we increment A, we decrement C. And we keep doing that until C is 0. So that is another way of saying just replace A with add C to A. No, and make C set C to 0. We don't have an add, so we couldn't make an add. It's not too slow though, so we don't need to worry about that yet. So that's one thing that we can change. Replace these 3 with just move the contents of C into A. Basically, we want to get rid of the jumps. Now we decrement D. Jump, not 0, D, minus 5. 2, 3, 4. 1, 2, 3, 4, 5. Okay, fine. So we've incremented A, decremented C. So basically, where were we? That becomes 0, and that becomes 11. Before we move on to dec D. So now 1, 1, 1, 1, 0, 11. And then we repeat all 1, 2, 3, 4, 5. Copy B to C. So we do 11, 11, 11, 11. I see. Alright, so what this is doing, basically, is we're taking B to C. Wait, so, yeah. Taking B, moving it into, adding it to A, and doing that D times. So A will eventually be B times D. This is just a way of doing multiply B and D and put the contents in A. So I could replace that with one command, mult. I could make a new mult command. All right. What else? So that will keep going until D is 0. So B and D but the problem is, what if the toggles, where are the toggles? Because if the toggles interfere with that, then toggle C, what could C be here? C is one of those that messes everything up. All right, so let's just keep going. So 11, 11, 11, 11. So all right, so just take these out. From here, we're doing B times D. So 11 times 12. 32. And then B ends up B doesn't actually ever change. C 0, D is 0. Okay, because those are like the temp values. All right, then we get as far as PC 11, instruction 11. Decrement B. So we get 1, 3, 2, 10, 0, 0. Okay. Copy B to C. 3, 2, 10, 10, 0. PC to D. 1, 3, 2, 10, 10, 10. Decrement D. 3, 2, 10, 10, 9. Increment C. 3, 2, 10, 11, 9. Jump, not 0. D, minus 2. Sweet. So those last two, let's take those out. Jump, not 0. So we decrement D and increment C. So basically D is moved into C. So that's 20. Toggle C. C is 20. So we're toggling this one here. Even though we never used it. Fine. So that one would become copy. Now copy minus 16 to C. Okay. I don't fully see where all this is going. Copy minus 16 to C. So this is no longer JNZ. This is now copy. Copy 1 to C. So That should be 1. Where is the bulk of the loop happening? And copy 90 to C. C. Jump, not equal to 0, 90 D. So this jumps. That's a 90, so this jumps no matter what. I'm going to jump to D. Go back to the start. So we keep so this loops endlessly until the only thing that could get us out of this loop is this toggle. We need this toggle to toggle this jump, not 0, 90. When will that happen? Oh my god. We need that to change to a copy. And when that happens, whenever it happens, we'll end up with 90 being put in D. So we'll have, I don't know, question mark, 90. Increment A, increment D, jump not equal to Z, D minus 2. What? This will just go infinitely, won't it? Jump not 0, 90, D. Oh, no, that's not the only way we can get past this. The jumps. What? The copies could be changed to jumps, so this is ridiculous. But so far, all the jumps take us back. Do any jumps take us forward? This one takes us forward. Jump not equal to 0, 90. If this one gets toggled, I did the original toggle wrong. Toggle C doesn't toggle. God damn it. See, I want to replace this with a mult and this with a mult. The problem is I'm worried that the toggles will toggle those. Can that ever happen? So toggle C. Oh, there's only one toggle in this whole thing and it always toggles C. So what would C be at this point? C would be probably a positive number. C, copy C, text C, ink C. Jump not equal to 0, dead. Okay. C has to be positive. That means we'll never go back here. Unless... yeah, nothing can become a toggle. Okay, fine. So we can do something here. We can say... So this whole thing, 1, 2, 3, 4, 5. So it's copy B to C, inc A. So copy A to D. Still, I mean, 132 is not that much, but the jumps could make us do the multiplications a lot. All right, so ultimately we end up, okay, so what actually happens here? Where do we start from? So here, copy A to D. A becomes 0. A to B. So this whole segment here is basically doing A times A minus 1. We put A in B. That's A minus 1. We put A in D. We clear A, put B and C, and now we do all this stuff. So this whole thing can be replaced with mult 2 parameters. And this whole thing is, this whole section from 1 to 10 here replaces A with A times A minus 1. Okay, but that's not expensive operation. Now, will we ever jump back here? I don't know. Copy could change to a... No. So we agree that we decided that toggle will never toggle something behind it, because C will always be positive at this point. So let's not... The jumps could make anything happen, couldn't they? I don't really know how to do this. Like, I want to simplify this, but any jump could send us into one of these instructions, which will make the simplification invalid, surely. What can we say for sure? This one here. Alright, this one here. D has to be a negative number. And basically we're adding the absolute value of D to A. But any one of these could be toggled at this point. Sake. All right. Let's just print start printing stuff. What actually gets toggled? When we get stuck in the loop, where are we? Let's see. Okay, don't do part 1. Alright, print PC register, let's do that. Alright, go. So we're basically 5, 6, 7, 8, 9. We're doing 5, 6, 7, 8, 9 over and over again. Five, 6, 7, 5. No, it's just 5, 6, and 7. A is that. Ah, I see. Okay, if we do this mult, that might actually work. Alright, so the other thing I need to check is whenever we toggle, I want to know what we're toggling. Toggled I. Alright, let's see what we're toggling. We're never reaching the toggle because of the 'I thought my calculations determined that we would actually reach the toggle. Now I'm confused. What is... This loop is not that complex, it's only like 100. Ink A, Deck C. And now decrease D. Copy B to C. So yeah, we copy B into C. So yeah, B times D goes into A. A becomes B times D. Why? So when C gets to 0, we then decrease D. Okay. And then we do that again. So B goes in there. So ultimately, we would get B times D. Why are the numbers so big? I don't understand. Deck B, copy C, deck D, ink C, jump not equals set D minus 2. So why aren't we reaching toggle C? Maybe C is an invalid number at that point? Let's try. Toggle I. Maybe I is out of bounds. Stop. Ah. So the toggle numbers are invalid. Fine. Alright, I think we have enough to get started. So we want to change. We want a new. So this loop here goes 1, 2, 3, 4, 5. So this whole thing we would change. What does this whole thing mean? Copy B to C, ink A. So C and D will end up 0. So let me just write down here what the last things will be. Copy 0 to C, copy 0 to D. And A, we don't have an instruction for this yet, but we want A to be B times D. Okay, so should we say should we call that mult B D and put the result in A? All right, let's do that then. So we want to replace that 1, 2, 3, 4, 5, that lot with mult B, D, put the result in A, and then we just need to make sure to keep the invariant. Copy 0 to C, copy 0 to D. All right, let's do that. See where that gets us. We need to make sure we still get the correct answers for the old ones as well. So we need mult. Let's just call it mult, 3 characters. So it'll be mult these 2 numbers and put them in A. Okay, register A. So register 0, 1, 2, 3 okay. Equals register 1 times register 2. Let's try that now. What's going on? One, 3, 2. We haven't got the right answer for the first part. 42. That's... Wait, what? No, that's the answer for the example. Okay, just do part 1. And what did it used to be? One 3140. That means it doesn't work. Alright, print the toggles. I want to see what's getting toggled. Toggle 26, 24, 22, 20, 18. Okay, so it never toggles anything before. Good. Oh, damn. Hang on. This can change to a jump. Jump. No. Yeah, jump. No, but that'll be fine if that's a jump. These can change the jumps, okay. And these could go back. So this doesn't... These can be modified, so how... Alright, 26 is... doesn't exist. Okay, so 24 be line 25. That becomes a deck, right? So that can't be simplified unless 22 Hang on. Do we ever use the instructions before they get toggled? Alright, 18, 20, 22, 24, 26. Let's check these. If PC in 18, 20, 22, 24, 26, print C. So we toggle 26. We do visit 18. We toggle 24. We do visit 18. We toggle 22. We do visit 18, 20, 18, 18. So all of these can actually be toggled from the start, and then we could just remove the toggle, but... So we keep going until... 36, 32, 30, 28. It's going down by 2 each time. Because C is... something's happening to C. Alright, so... basically... jump. $18 will be this one. This becomes copy 1 to C. And then from then on, what happens? Then you copy 90 to C. $36, $34, $32, $30, $28. Quite a lot of people solved this actually, so I'm really confused what I'm doing wrong here. So 26, 24, 20, 26, 24, 22, 20, 18. Interesting. So basically, I think we have to talk, we just beforehand, we have to toggle, I don't know. I could re-toggle things later on, so we can't assume anything. How long have we been going? Almost 2 hours. Get it. How did people solve this? We know that this kind of is equivalent to multiplying, but the problem is the toggles ruin it, so... Alright, but we know that the toggles don't change anything before. That's fine. But the mult, we do have this mult to deal with. Right, we gotta print all the jumps, work out where we're jumping to. Okay, where do we jump to? Jump 5, 4, 5, 4, 5, 4, and 13. Jump to 2. Really? So 5 is this one. That is a problem, because that means we can't... Well... If we're jumping to 5, that means we can't compress this. Because... Okay, jump 4, 5... Oh, no, that's... 6, 4... Hang on. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Okay. Ah, okay, that's sort of correct. Okay, fine. Alright, that's as expected. 4s and 5s. We've got 21s. So why can't we just do that mult thing again? What is wrong here? Why doesn't it work? One, two, three, four, 5. Copy B to C, then C goes into A. And then decrement D, and jump 1, 2, 3, 4, 5. So A goes to A. Oh! This bit's wrong. It should actually be A plus B times D. We're adding to whatever's already in A. Ignore the fact that there's 0 here because it won't always be. Okay, so if we take that and replace it with oh my god, okay, so let's do... let's say mul BDA add a, I don't know, mul BD, put the result in C, add A to C and put the result in A, and then 0 C and 0 D. I think that's equivalent to that big loop. Let's try that. So we need add so be plus. All right, try that. The heck? It's not equivalent. Mult BD, put the result in C. Add A to C, put the result in A. So A ends up A plus BD, right? And now just zero out C and D. What's wrong with that? Alright, let's start smaller. Alright, so inc A, dec C, jump C to -2. Let's just replace that with something. Right, so the answer we should be getting is 13140. Let's try placing. So we want A to become A plus C. So we do add A, C, and put the result in A. Alright, will that work? Fuck. Oh, because the number of instructions is... oh, damn it. We need dummy instructions now. Okay, I can do that. So let's go back. Alright, so what did I... initially I wanted... okay, so I wanted to replace this... 1, 2, 3, 4, 5. This whole thing, that's 6 instructions with mult BDA, add a mult BDC, add ACA, okay, then 0 out C, 0 out D, and now I need to waste 2 more instructions to keep the locations the same. So just do like inc 1, inc 1. 1, 2, 3, 1, 2, 3, 4, 5, 6. Now will that work? Damn it. Why? Jump 13, jump 2. Jump 13, jump 2. I don't think... What, have I done something wrong here? Okay. So deck B should be at 11. Go back, go back, go back, go back, go back. It is. So why? 1314. Okay, try the add thing. So let's say this section here. Just do add. So we want deck C. So add A, C, put the result in A. Copy 0 to C, and then we want a dummy instruction, inc 1. Come on, come on, come on. Yes, it's a start. Now what? Jump 4, jump 2, jump 4, jump 2, jump 4. So sometimes we jump 2 here. Sometimes we jump to 4. So I would think we can now change this one. Maybe I misunderstood what it's doing. So copy B to C. Copy B to C. Is copy B to C. Maybe we can just add A to B and put the result in A. Take that one out and put another inc 1 to make the numbers match, to make the instructions line up. Okay, does that still work? Yes, okay, fine, we're getting there. So what are the jumps again? Jump 4. Okay, jump 4. So we jump here. We keep doing this over and over again. Fine. Add A. Add B to put the result in A. Copy 0 to C. Inc 1, decrease D. So basically we do this D times. 1, 2, 3, 4, 5. So we should be able to just say so we end up, so we start with A, B, C, D. We end up with D will definitely be 0. In fact, C and D will be 0s. B will never change. And A So it'd be A plus B times D. I've tried that before. Be A plus BD. Alright, try again. So we change this to mult BD, put the result in C, and we're adding an instruction. So take away one of these. Add A, C, put the result in A. Zero out C, and then change D to be 0. That, I feel like that should be equivalent now. Let's try it. Please. Yes, we're getting somewhere. We've taken out a loop. Now what? We do a lot of jump 13s, jump 2s. Okay, fine. Let's try running it on part 2, see what kind of where we get with that. I don't think that'll be enough, but please, please, please. Was that all we had to do? I could have done that really quickly early on, but I assumed that the toggle will interfere with it, so I didn't do that. Oh, that could have been done so much quicker if I had just gone with my gut. I mean, what's the worst that can happen? I get the wrong answer and I just go back to what I had before. So I should have just replaced those 5 lines with the multiplication and just left it at that. Yeah, I performed terribly on that. There's no way ChatGPT is going to solve this, is it? I think he's going to fail this one. Like, he's not going to be able to analyze. Alright, so it's 23. He'll solve part 1. Wait. Oh, no, stop. He's doing... Oh, no, he's doing it right. He's doing it right, okay. How does he know what copy and ink and deck do, though? I haven't told him. I guess he just knows. Right. Key error 1. Parts 1. Huh? Parts 1 registers. I think it's not accounting for Alright, let's give him some more instructions. Alright, let's see if he can do it now. Same error. Alright, I'll just copy the error. One is not found. Okay. I think he's not making sure he's using registers instead of ints as appropriate. No, you shouldn't be. No, that's wrong. That's a wrong fix. Wrong fix. No, that's not gonna work. He's making it worse now because he's setting default values when you should actually be erroring out if there's an invalid register being called. And it actually gives the same error. I think I'm just going to call this a loss for ChatGPT because he's not going to solve part 2. But anyway, he's failing to solve part 1, so... Is there any information we should have given him, really? No. We gave him all the information. Still an error, but it's a different error. The value of y. But it's not y, it's c. Okay, whatever. Right, I think he's actually improving it. I also need to change the input to be the original input because I've modified it, haven't I? It's just running in an infinite loop. Yeah, but you shouldn't need these additional checks to prevent infinite loops. There should be no infinite loops. No. This is wrong. The infinite loop is better than what you're doing. You're now breaking out after a certain number of steps. 1000. Yeah, but the registers are changing. So... Okay. I'll play along, see where this takes us. I mean, I like what he's doing here. This is actually quite smart. Alright, let's tell him it's endlessly... We need to modify the GANZ C-2 instruction to conditionally break out of the loop when the value of register C is non-zero. Huh? But you're supposed to do that anyway. That's what GNZ does. That's the point of GNZ. No. He's making it specific to the... Oh my god. Okay, this is a fail. There's no way he'll be able to do part 2 either. Return. Okay, that actually terminates. Oh, he's never... Instructions, registers. God, he didn't give me a main function. Because he assumed I was just keeping it from before. Okay, let me just paste that in. Nope, same issue. Nope, I'm calling it. It's a fail. Failed. Alright. We're actually catching up now. We won't be able to catch up fully. There aren't enough problems left. But these later problems are actually too hard for ChatGPT to solve. That's kind of makes me feel good. There's only 2 problems left. Do we think we can solve them? Let's have a look at the times. $23. Oh, these ones look harder. But this one, pretty much everyone got 2 stars, so everyone who attempted it got 2 stars. This one, lots of people got stuck on 1 star. Okay. Oh no, but the last one is only 1 part. Okay, come on, let's do it. Let's go for 24. Oh, why did I click that? Alright, Air duct spelunking. You finally met your match. The doors that provide access to the roof are locked tight, and all of the controls of related electronics are inaccessible. You simply can't reach them. The robot that cleans the air ducts, however, can. It's not a very fast little robot, but you reconfigure it to be able to interface with some of the exposed wires that have been routed through the HVAC system. If you can direct it to each of these locations, you should be able to bypass the security controls. You extract the duct layout of the area. from some blueprints you acquired and create a map with the relevant locations marked. Okay. Oh my god, right. It's a maze, basically. 0 is your current location from which the cleaning robot embarks. The other numbers are, in no particular order, the locations the robot needs to visit at least once each. Walls are marked as hash, and open passages are marked as dot. Numbers behave like open passages, okay? For example, suppose you have a map like the following. To reach all of the points of interest as quickly as possible, you would have the robot take the following path. 0 to 4, 4 to 1, 1 to 2, 2 to 3. Since the robot isn't very fast, you'll need to find it the shortest route. This path is the fewest steps. In the above example, a total of 14 required to start 0 and then visit every other location at least once. So it's a traveling salesman problem, but with only a few. Given your actual map starting from location 0, what is the fewest number of steps required to visit every non-zero number on the map at least once? So I think we want to do repeated breadth first search to find the distance between any pair of numbers. And that makes us a subgraph, like a contracted graph. And then on that graph, we just try all permutations. See which is quickest. So, okay. I can do this. I think I would do this quicker than the previous problem, so... It's Christmas Eve. Alright, so we want a, let's say, grid equals that for line in f.readlines. Also, we want, let's say, POIs equals that. So we'll just mark the locations of points of interest, which are the numbers. Grid dot append line dot strip. Okay, for car. For I car in enumerates, let's just go through the line. Actually, let's not do that. At the end, okay, so we've got a grid. Let's say width, so n, the length, the height equals length grid, m equals length grid 0, So for I in range n, for j in range m, if grid I j dot is digit, then put it into the POI. Let's say I j, no, POI grid I j equals, so the it's just equals to the location ij. Okay, so let's print POI. Let's just have a look at that. 0, 1, 2, 3. Okay, good. Now, define BFS start end. Could do A star, but I think this will be fine. This will give us the distance from start to end. Should I code this again from scratch, or should we just copy something from before? Let's copy from before. I'm a bit lazy. Dude, should we just do A star? Let's just do it. It's probably overkill, but all right. So what are we? Is it only up, down, left, right? Yeah, I guess so, yeah. All right, so we've got a heuristic of a, so we've got a start and a goal. Heuristic of a pause is absolute value of goal 0 minus pause 0. So the Manhattan distance. Okay. All right, so we've got priority queue. So we've got start and we've got a goal. So queued up 0 plus h star to start, good. Dist from start to 0, 0. Close set equals the set. All right. While not queue.empty, current equals queue.end. Close.set.current. All right. If current equals goal, that's what we want to say. If current is equal to goal, turn this to current. All right. So neighbor. All right. Now we need to get neighbors. So for DIDJ in let's say -1 0 1 0 0 -1 1 that's 0 1 neighbor I neighbor j equals current 0 plus di current 1 plus dj if this position is in the closed set. We continue. If it's in dist and okay, let's just say we need to check that we're not out of bounds. If 0 is less than or equal to neighbor I is less than n and 0 is less than or equal to neighbor j is less than m, do all this. Okay. Huh? Okay. Neighbor equals that. We haven't actually looked at the grid. So if grid neighbor I neighbor j is hash, continue. So we're moving to a space which is either empty space or number. If neighbor is in dist and we found a better distance before, I think there's a unique path, isn't there? Well, we don't know, maybe not. Continue. Dist neighbor equals dist current plus 1. Queued up put dist neighbor plus the heuristic neighbor. Right. Or okay, so paths. We're gonna make a new distance table. So for x in POI.keys or y in POI.keys. Paths x, y equals, and then we run a star to find the closest, the distance between the two. Star from x to POI x to POI y. Now print paths. So if we've got this, we're almost there. So 0, 0, 0, 0, 0, 1, 92, 0, 3, 288, 0, 2, 30. Perfect. Right now, the final thing is we want to try all. So we start from 0. So we need permutations. ITER tools, import permutations for R in permutations of, so we want QI.keys, but we want to ignore 0 because we start with, no wait, yeah, okay, minus is that, does that even work? Yeah, okay, that works. Just make sure we're getting the right permutations here. Yes. No. Yes. Okay. It's in lexicographical ordering. All right, so best equals none. All right, so now distance equals 0. Distance equals, start with paths from 0 to R0, and for I in range paths D plus equal R I, the distance from I to I plus 1. So given this permutation, we're trying to go in that order on purpose. Now we may even cross one of those numbers again. Don't think that matters. Let's say best equals max of paths.keys times length of paths. Okay, so that's just bigger than any possible path. Alright, so best equals min best D, and now print D. Alright, what's this going to give us? Tuple index out of range. Ah, use R, not R, not paths. Okay. Less than is not supported between int and tuple. Min, best, D. that should be values. We're using integers there. Multiply words. 1076. Alright, Alright, let's try it. No, it's too high. Okay, let's try the example. $22. Visit every other location at least once. Zero to 4, 4 to 1, 1 to 2, 2 to 3. So let's print all our data. So okay, we've said 0 to 0 is 0, 0 to 1 is 2, 0 to 2 is 8. Is that right? 2, 3, 4, 5, 6, 7, 8. Okay. 0 to 4 is 2. Yeah. It looks like these numbers are correct. 0 to 3 is 10. Huh? Yes, that's right. What about other numbers down here? 4 to 3, 8? Yes. Okay, so that table looks correct. Try all permutations then. So if E is less than best, print R D. Okay, so we found. Huh? Oh crap! We're printing D instead of best. 14. There we go. Okay, change this. For 1, 2. It was a very minor error. Correct. Of course, if you leave the cleaning robot somewhere weird, someone is bound to notice. What is the fewest number of steps required to start at 0, visit every non-zero numbered marked on the map at least once, and then return to 0? So we're just increasing the complexity a bit. It'll multiply by a factor of 8. So just be 8 times slower, won't it? Alright, for part 2. So parts we reuse. Okay, hang on. We reuse parts. So this is part 1. Part 2. We don't need to be printing all this stuff. So we want to do that. Best equals, and just in case, let's increase this by 1. Oh, it's including loads of... Okay, that doesn't matter. Just take that out. Alright, so for R in permutations, those... We do D equals paths. Okay, so we want to actually add... Hang on. We're not actually increasing the complexity here. We're just adding a number to this. There's... What? We're just doing... From R -1 to... Wait, do we have... We can revisit numbers, can't we? This might be problematic if we're not allowed to revisit. Otherwise, we just add the distance it takes for the last one to get from the last one to back to 0. $664? That's suspiciously easy. Part 2. Huh. I don't see, no matter how you've coded it, I don't see why that would be hard. You literally just add the distance to 0, which you probably already computed because you kind of needed it, didn't you? If you've already computed 0 distances from 0 to numbers. I don't see how else people would have coded it. Could they have? Yeah, I think that was a freebie. Right. I'm pretty sure ChatGPT will solve this one. This one's doable. So it's... Oh, it took out some dots. Some... Oh, no, that's fine. Just not using fixed width characters. So, what does he do? Get neighbors, get shortest path. Shortest distance equals shortest path. So, shortest path. Shortest path. How does this work? He's not using any permutations? Let's see if it works at least. I don't think you can do it without permutations. Yeah. You can't, unless you're backtracking, I don't know. Or ChatGPT. Shortest distance equals shortest path. Shortest path turns unhashable type set if current collected. Yeah, you can't do that. But this is weird. So, is he taking a non-self-intersecting path? Because I don't think that's valid, because there could be paths where you have to revisit a number you've visited before to get to the next one. So he's making an assumption there, and that might be false. Either way, we get this error, so... Oh. Yeah, okay. Two, four, yeah, okay. If this is... And shortest path. This is just... Place the shortest path. Okay. Alright, it's running. 414. What? Oh, no, it's wrong. I thought he solved it. It's wrong. The answer is 412. So he is... There is... So basically, he's found a path which visits each number, I think, exactly once. Or no, he's found a non-self-intersecting path that visits every node. But if you relax the condition to allow self-intersecting paths, you can actually save time somewhere. Yeah, so the example they gave is making him think you are not allowed to self-intersect. Alright, so all I can tell him is, yeah, so his answer was too high. Error in the condition for checking if all points except 0 have been collected. Here's the corrected version of the shortest path. Yeah, but it's still non-self-intersecting. Unless they've been generous with the input. What's running? Now it doesn't work. He was close to begin with. I think he's failed this one. That's a shame because I really thought he would pass this one. He calls them points of interest as well. He copies all my variable names. What if he's watching this stream? What if he's stream sniping? That would be so meta. No, it doesn't. Well, I've been trying it, but it doesn't look like it. Yeah, I think he's made an assumption. This is a traveling salesman problem, not a trial non-self intersecting. It's a it's not traveling salesman. Traveling salesman, you can only visit each node once. Here, you're allowed. It's relaxed. It's still hard to solve though. But okay, whatever. That's a fail for ChatGPT. 816. So ChatGPT is only twice as good as me. It's comforting. Alright, clock signal. You open the door and find yourself on the roof. The city sprawls away from you for miles and miles. There's not much time now, it's already Christmas, but you're nowhere near the North Pole. Much too far to deliver these stars to the sleigh in time. However, maybe the huge antenna up here can offer a solution. After all, the sleigh doesn't need the stars exactly, it needs the timing data they provide. And you happen to have a massive signal generator right here. You connect the stars you have to your prototype computer, connect that to the antenna and begin a transmission. Nothing happens. Nothing happens. You call the service number printed on the side of the antenna and quickly explain the situation. I'm not sure what kind of equipment you have connected over there, he says, but you need a clock signal. You try to explain that this is a signal for a clock. No, a clock signal, timing information, so the antenna computer knows how to read the data you're sending it. An endless alternating pattern of 010101, he trails off. You ask if the antenna can handle a clock signal at the frequency you would need to use for the data from the stars. There's no way it can. The only antenna we've installed capable of that is on top of a top secret Easter Bunny installation. You're definitely not. You hang up the phone. What? You've extracted the antenna's clock signal generation SymBunny code, your puzzle input. It looks mostly compatible with code you worked on just recently. Oh no. No, not that. This antenna code, being a signal generator, uses one extra instruction. Out X transmits X as the next value for the clock signal. Okay. The code takes a value by register A that describes the signal to generate, but you're not sure how it's used. You'll have to find the input to produce the right signal through experimentation. What is the lowest positive integer that can be used to initialize register A and cause the code to output a clock signal of 0101 repeating forever? We try to solve the halting problem here. It's unsolvable, but we might be able to solve it if we're being smart. And find the lowest positive integer that can be used to initialize register A and cause the code to output a clock signal of 0101. So we can kind of... Oh my god, okay. Alright. We got no toggle. Thank goodness. Right, we'll use the updated code, I guess. 20, what was it, 23? So with input ins equals that. So we don't have mult or add or toggle, just take those out. Register, we start with, oh, we choose And what letters are we dealing with here? B, C, D, as before. Okay. So let's just start with 0 then. Print, execute. We don't care what A is. But we want to see the out signal. Okay. So we got out. What outs do we have here? It's just out B. Either an integer or the value of a register. Well, let's code it properly, even though it's clearly just B. All right, x equals for now. Let's just print x. All right, let's see. Print execute. So what's happening? It's never reaching the out. All right, let's have a quick look at this. So we've got could be A to D, could be 9 to... Oh, we've got this again. Maybe we do want the mult. Let's see. Alright, it doesn't like this. Let's try. It's not going to be 0 though, is it? Let's just try 1. I know it's probably going to be some really high integer, but try 1,000 or something. Let's try and get it to produce an out. Alright, let's figure out where it's getting stuck. Huh? Nothing's happening. It's stuck on instruction 0. Oh, I cut out the PC plus equal 1. We're not increasing the program counter. Alright, let's try that. We don't need to print these jumps. Just prints 18. Print 1. Two. So what would the loop look like if we get stuck into a loop? So it'd be out, B, jump, not Z, A, minus 19. Jump, not Z. So this one always takes us back to this one. This one depends on A. And that takes us back to this one. Jump, not Z, 0, 0. What? So this doesn't do anything. Should we take it out? Why is it there? No, don't take it out because that will affect things. Okay. So we want the... All right, how about we do... We keep... All right, for X in let's finally use this thing. So this counts from Does it do what I think it does? It goes 0 upwards. Yeah, okay. Okay, register. Equals X. All right, so let's not print the X's. So we want, okay, execute. So the outs equals just this list here. Now, if length outs, okay, so X, put it in this list. Outs dot append X. If length, if, okay, let's look at the last 100. If length of outs is greater than 100, and it's a pattern of pairs repeating. So if tuple outs is the same as tuple of outs 0 outs 1 multiplied by 50, so it's back repeated. Then we break out. Then return out. So out equals execute. So we get back the list of repeating pairs, and now we want if tuple out, let's say -100 onwards. So we keep going until it found some sort of pattern. Now we just need to say if set of outs is dot is equal to set of, I don't know, 0, 1. That should be equivalent, right? Print x break. Will this work? There's all kinds of things that can happen though. Let's have a look. Wait, what's going on? 18. What are we printing? Take that out. I don't think it's getting to the outs bit. Okay, we need to do the mult thing as well. Alright, so let's have a look. So we got mult and add. Mul and add. Alright, so replace, let's have a look. Can we ever see anything in out? Alright, well, we can trust what we did before, so we have 1, 2, 3, 4, 5. Copy 282 to B. Where's the scratch? So we've got A, B, C, D. So we copy 282 to B. So A, 282, C, D. Inc D, A, 282, C, D plus 1. Dec B. Alright, so we will end up with that being 0 and that being 282. Dec C jump 1, 2, 3, 4, 5. So we do basically C times 282. So that and B will end up 0 and C will end up 0. And D will end up that and A is untouched. All right, so we can replace that. That's 1, 2, 3, 4, 5, 6. So we can say multiply 282. I'm gonna have to change the multiply slightly. C, put the result in B, add B to D, put the result in D, then copy 0 to B, copy 0 to C, 1, 2, 3, 4, and then link 1, 5, 6. So that's equivalent, right? Except mult we just let's say take out one instruction, just do a hack here. Copy 282 to C. Yeah. Alright, let's try that. So that should be equivalent. 282. What? Oh. Multiply C. Oh, no. Copy that to B. No. B. Put 282 in B, multiply whatever B is by C, put it in B. Multiply B, add B to D. Okay, that's fine. 1, 2, 3, 4, 5, 6. All right, let's try that. So that simplifies a bit, but what's going to happen now? Do we ever get an out? Zero. Oh God. We do get zeros and ones. How do we know when we're stuck in a loop? All right, let's say length outs is greater than 1,000. Let's just return whatever it is. Return outs the last 100. So wait, you just do it 1,000 times and then return the last 100. And now we want to say okay, now if tuple of outs is equal to tuple of 0, 1 times 50 or 1, 0, 50 break. Alright, try this. How far are we gonna have to go? counting in binary upwards or something. But they said loop forever, so that won't necessarily mean anything. Oh my god, how on earth are we supposed to do this? Because we don't know when it will loop forever. We need a concrete way of deciding when it's going to loop forever. So we need to find a condition that will prove it. Because this, it does, in 1000 might not be enough. We don't know. What would actually an infinite loop actually be? Can we cut out some of these other ones as well? So we got null. What other things have we got? What's this? 1, 2, 3, 4, 5, 6, 7. So let's have a look at this one. So we A, B, C, D. So we copy 2 to C. Right. A, B, 2, D. Jump. Jump not Z, jump not 0, 1. So that just says jump. 1, 2, 3, 4, 5, 6. What? Is there anything we can cut out here? Jump, jump. Okay, this one. How about this? Jump not Z, 1 minus 4. Okay. That always jumps 1, 2, 3, 4. Jump not Z, C is 2. Deck B, deck C. So this keeps Alright, this one's interesting. Okay, so that will Huh? It found a pattern, but we don't know if that's actually infinite loop. 192. Oh! Like, how can we prove that that's actually an infinite loop? I suppose when we find that, we can then go through it with 192 and try and find some sort of proof that it will actually loop. Like what actually happens. Don't know. Don't care at this point. Part 2. The antenna is ready. Now all you need is the 50 stars required to generate the signal for the sleigh, but you don't have enough. You look toward the sky in desperation, suddenly noticing that a lone star has been installed at the top of the antenna. Only 49 more to go. You have enough stars to transmit the signal. You activate all 50 stars and transmit the signal. The star atop the antenna begins to glow. Suddenly you see the sleigh fly past you. Looks like Santa was already waiting for your signal. Congratulations! You've finished every puzzle in Advent of Code 2016. So yeah, this is the guy behind all this stuff. That's the full URL, was.tr. Okay, cool. There we go. Interesting. That was an interesting year. It was very cryptography based. He really liked his codes that year. That's cool. Oh, we still have to do the ChatGPT thing. I wonder if he'll be able to do this one. We'll tell him what the instructions mean. Okay, so we do that, but we also have to take the instructions from part 12, day 12. Take this out, give this information as well. So we say is he going to tell me this is impossible because it's the halting problem? Okay, well, he's doing the, find lowest clock signal instructions, range 10,000. If output equals run assembly. Yeah, but it might not start with 0, 1. But then it could. Maybe they were just generous here. I was thinking it could start with some random numbers and then eventually converge at 0, 1, but maybe... Actually, now that I think about it, cause the code to output a clock signal of 0, 1, 0, 1, repeating forever. I think it's actually supposed to even start with 0 and then go to 1. So what I did was actually overkill. In fact, okay, I'll let me just, before I use his code, let me just adjust my code. So let's say if length outs is equals 100, return outs. Okay. And now just say if tuple outs is equal to that times 50. That should be much faster, right? Let's try that. Yeah. That's what I should have done. Maybe we could drop it even lower. 50, 20, 30. Just make sure it still works. Alright, so I think ChatGPT will actually solve this. Yeah, okay, so now oops. Oh, he's making these errors again. It's not reading properly. Come on, I actually want him to solve it this time. Nope. Modifying the instructions. Yeah, don't touch the instructions. You're doing modifying the instructions. Nope. I don't think that's the issue, but okay. No. Oh, he's not figuring out what the error is. I think he's not correctly using both letters and numbers, integrating them. I don't think that's the issue. Alright, last attempt. Oh, different error. Okay, we might be getting somewhere then. Catch any malformed. There's no malformed instructions. Oh no. Did I? Oh, I've given him my mul and add. That's the problem. Idiot. Get the original input. Oh, I almost penalized. I almost gave him the loss there. Ah, it's still not working. Hang on. List index out of range. Alright, let's try his new code then. Same error. No, 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 no. There's no unexpected. I don't know what the issue is, but... Oh, it's running out. Alright, let it run. I mean, if it's running out, it's probably going to be correct. Oh, there is a problem here. He's doing while PC is less than length instructions. It's supposed to get stuck in an infinite loop. He's not breaking out. Yeah, it's... Okay. Yeah, he doesn't get it. He has to break out of the infinite loop. We're finding an infinite loop, but we're not staying in the infinite loop. No, 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 that's not the issue. That's not the issue. Okay, because I gave him bad input before, I've got to be fair to him and at least try a couple more attempts. Oh, he's slowed down. Oh, that's because I'm running this. And output. Well, no. That's no. Now you're introducing a new error. It was correct before over 2 because it's 0, 1. This is gonna be worse now. No, it's infinite loop. Right, let's just tell him what the problem is. The problem is that the SimBunny code is supposed to get stuck in an infinite loop. We have to detect it and break out manually. Oh my god, he's so smart. But yeah, but this doesn't count as a win. detect infinite if length output is greater or equal to 2. Wait, what? Why are you checking only 2? Alright, this doesn't look right. One. Yeah, because now you're... Okay, forget it. You lose. Still wrong. Never mind. Bye. Alright. Well, let's update the scoreboard. Stream 9. So I'm more than half as good as ChatGPT. Alright, well, that was Advent of Code 2016. So next time I'll move on to 17, 18, 19, 21, and I'll do 23 when it's live, which will be fun. I don't think I'll be able to solve all these before the actual Christmas, but yeah, it was good. I mean, I think I enjoyed the other months more. I think this one kind of spent a lot of time in the realms of cryptography and Sembunny. I think it could have branched out a bit more, but it was good. And those last couple of problems were actually very smart. Especially, I think it was 22. Yeah, that one was a good one. It was a giant red herring. 23, what was this? That one is kind of smart, but I also didn't like it because it's very difficult to judge what you're supposed to do. Okay, well, that's it. You can expect that I'll return to Advent of Code in maybe a month or two. Until then, just keep coding, or just switch to ChatGPT. He's almost twice as good, but he does struggle with the clever questions. This is why the best questions are the ones that are really clever, and that ChatGPT can't solve them because you have to really think humanly about them. Like problem 22, for example. Well, no, but he did solve 22, didn't he? Yeah, actually, he did sort of solve it. I don't think he solved it, but he had the right idea for it. All right. That's all for this month. See you in 2017.